Good day, everybody. Let's look at another example when we use rock data. And in this case, we're going to look at the slope. We're going to excavate slope in rocks. And what we know that the rock is sandstone. Please read the text of the problem in the description. So we know that it's sandstone and the slope is 35 meters high. So the unconfined compressive strength of this rock is 60 MPa and the density is 2.3 grams per cubic centimeters. So the rock mass structure can be described as very blocky, so it has lots of discontinuities. And when we check the surface of the discontinuities, the surface conditions were good. So the slope will be blasted, so we can describe it as good blasting, and then it will be mechanically excavated. So what we need to do, we need to estimate the strength characteristics of this rock mass. And we're not given any data from laboratory tests, so we'll have to use the reference data. The way we're going to do it, we just start new file here. And we already have this reference data here, the one that we can use. So this is sigma CI. So it's given to us and it's 60 MPa. So we can put 60 here. Sometimes, if you do very rough estimation and you only know the type of rock, well, you can still get some estimates of the strength. You click this button and then you just find, for example, sandstone. What we deal, what is sandstone? Schist, shale, sandstone. So it will give you estimates from 50 to 100, right? So, and average 75. But in our case, we know that UCS at 60, so we keep it 60 here. Geological strength index, what we are just given that the rock mass is very blocky. So let's see what we have, very blocky. And surface conditions described as good. So good, blocky, somewhere here. So I click 56. Well, maybe you'll get something like 57, 55. That's okay. So that's plus minus 5 points. 56. Then we're going to click OK. And this constant, Hook-Brown constant MI, we can get it again based on the reference data. We know that we deal with sandstone. I believe it's around 17 or sandstone 17. Again, if you don't know exactly the type of the rock, you can probably go through rock type, sedimentary, it will give some ideas, texture, medium, coarse, but we just know this is sandstone and it's 17. Click OK. Disturbance. So let's go to disturbance. We have two applications. We deal with slopes. So we click slopes and we have a good blasting. So, well, disturbance is 0.7. When poor blasting, disturbance is 1, which is the highest value. Okay, click here. Okay. And the final piece, we just look at the application. So we deal with slopes. Then we're given the unit weight of, density of 2.3 grams per cubic centimeters. So when we change it to unit weight, watch my videos how to change the density to unit weight. That will be approximately 0.22. Um, and then slope height, it's 35. We change to 35, so we're just adjusting the principal stresses. And that's the characteristics that we're after. So here you will have UCS of the rock mass. So you see it drops from 60, which is just core samples, intact core samples. When we apply it to the whole rock mass, the strength will drop to 2.4 MPa. The tensile strength is also pretty low, it's 0.067, so it's negative because it's tensile strength. Um, And we can also get cohesion and friction angle. Let's say for slope stability, that will be very important characteristics. That's what we use most of the time to estimate the safety of a slope. So that's how we use reference data in RocData. It's pretty simple. Everything is already built in. So we just need to find the right parameters. But again, remember that it's estimation. That's not very precise data, but at least it will give you some idea about the strengths. Well, thanks for watching this video. Have a nice day. Bye.